Hey guys, welcome back. In this video, I'm going to teach you how to use L'Hopital's rule. And basically, what L'Hopital's rule says is when finding the limit, if you end up with an indeterminate form, okay, so I got to explain what that is, you can take the derivative of the numerator alone and the denominator alone, and then we reapply the limit. So an indeterminate form would be 0 over 0, or infinity over infinity, or negative infinity over negative infinity, and so on. Those are called indeterminate forms. So we need to get, in order for us to use L'Hopital's rule, you need to get one of these three, okay? So let's try an example. It's actually very simple, but some of them can be really challenging to get in this form, okay? So here's a problem. It says the limit as x approaches 2 of this function x to the third minus 7x squared plus 10x divided by x squared plus x minus 6. When we are working with limits, the first thing we do is we apply the limit. It's almost like direct substitution. So I have 8 minus 28 plus 20. That makes 0. And then we have 4 plus 2 minus 6. That makes 0. Because we have 0 over 0, L'Hopital's rule says, why don't we take the derivative of the top by itself? So that's going to be 3x squared. Let's take minus 14x and then plus 10. And then we're going to take the derivative of the bottom. So that's going to be 2x plus 1. We're going to reapply the limit. And what's going to happen here is I'm going to have 3 times 2 squared minus 14 times 2 plus 10 over 2 times 2 plus 1. I know that's not going to give me a 0 over 0, so I'm basically going to be done after I calculate this. The denominator gives me 5. The numerator, I wish I did this earlier, but that's okay. That's going to be 12. That's going to be 28. That's going to be 10. So that's going to be negative 6. So the limit as x approaches 2 for this function right here is negative 6/5 or negative 1.2. You can always use a calculator to confirm your answer, but obviously if you're taking the AP, you can't use a calculator for this problem. Okay, so that's basically how we use L'Hopital's rule. But I need you to stay with me throughout this throughout this video, because some of the problems are going to get more challenging. This actual problem came from the Calculus BC. So I took it off, I think it was problem number 2 on the 2008. So first thing we do is the limit as x approaches 0. You're going to get e to the 0 minus 1 over tan 0. So e to the negative 1 over tan of 0 is 0. So in this case, I cannot use L'Hopital's rule because I don't have 0 over 0. I actually have a number over 0, okay? So in this case here, I'm just going to end up with does not exist, okay? So do not start this problem just by taking derivatives. It must be one of those indeterminate forms, all right? So this problem is done. So the answer is does not exist. In this problem here, we're going to get 0, because sine of 0 is 0, and we're going to get 2. Now remind yourself, e to the 0 is 1. 1 times 2 is 2. 2 minus 1 is 1. The natural log of 1 is 0, so I have 0 over 0. I can apply L'Hopital's rule here. So L'Hopital's rule says take the derivative of the top by itself, take the derivative of the bottom by itself. So the derivative of natural log is 1 over the inside times the derivative of the inside. The derivative of 2e to the x is 2e to the x, okay? And then the derivative of minus 1 is basically 0. All right, so what happens here? Well, please do not cancel anything out. You're going to rewrite this as cosine x over 2e to the x over this here. But that's like a keep, change, flip, right? So we're going to keep cosine x over 2e to the x. Sorry, let me get rid of that. Divided by 2e to the x over 2e to the x minus 1. And from there, I'm going to flip that around. And so I have cosine x times 2e to the x minus 1 over 2e to the x. Now, when you go back to resubstitute the limit as x approaches 0 into the red part here, you're going to get 1 times e to the 0 is 1. 2 times 1 is 2, minus 1 is 1. And then on the bottom, you basically get 2 e to the 0, which is 1. So you're going to get 1/2 for this entire answer. Pause the video and try the problem yourself and see if you come up with the same thing. First step, get an indeterminate form. After that, take the derivative of sine by itself, take the derivative of the natural log by itself. We're going to keep, change, flip. And then we're going to just reapply the 0, and you end up with 1/2. So the limit as x approaches 0 for that function is going to be 1/2. Here we go. What happens here? Well, we know that sine of 0, pi, 2 pi, 3 pi, 4 pi, and so on are all 0. So sine of 0 and any multiple of 180 degrees is 0. So this problem here is asking you, what is the limit as x approaches -4? So that's going to be 0, and that's going to be 0. So let's take the derivative of sine angle. The derivative of sine angle is cosine angle times the derivative of the angle, and the derivative of w squared minus 16 is 2 times w. You're going to reapply, okay? And then we have a -8 on the bottom, we have a pi on top. Now cosine -4 pi is either going to be, it's going to be 1 or -1. So I have to think about it. So every 2 pi it's 1. So every 4 pi it's 1. So it's just going to be 1. So it's going to be pi over -8. So that's my answer for this person. But remind yourself that you need to get it into this form before you can even possibly take the derivative. Okay? Natural log of infinity, even though natural log grows the slowest, it still keeps growing. So the natural log of infinity is infinity. And if you take infinity squared, you get infinity also. So that's an indeterminate form. And so we're going to take the derivative of that. So 1 over 3t times 3, that's just the numerator, over 2t. All you guys have to do is cancel. So 3 cancels out with the 3, you get 1 over t, divided by 2t over 1. If you keep, change, flip, then we're going to have 1 over t times 1 over 2t. So that's going to be 2t squared. If you apply the limit and you have a huge number in the denominator, we know this from horizontal asymptotes, right? If you put a huge number, 1 over a huge number is 0. So this is actually 0. So I don't want to make the video too long, but I want to just point out one final thing. I took this one from the AP also. Okay, let me do this and then I'll show you my final step and then we're done with this video. Okay, you're going to, I took this from the 2003, I believe. Okay, so this is going to be 1 minus 1 minus 0 minus 0. So that's 0. On the bottom, it's also 0. So that's 0 over 0 from direct substitution. Be careful when you take the derivative, okay? E to the x is e to the x. That's 0. That's a -1. This here is -1/2 times 2 is -1 x to the first over 3x squared. Now look what's going to happen here. When you go back to put a 0 in, okay, when you go back to put a 0 in, e to the 0 is 1 minus 1 minus 0 over 0. Guess what? You got 0 over 0. You have to reapply L'Hopital's rule again using this now. Anytime, you got to keep doing it until the 0 over 0 disappears, okay? So in this case here, sorry, let me put the square back. Take the derivative again, you get e to the x. That disappears, and then this here becomes a -1, and then the bottom becomes 6x to the first. Guess what happens when you reapply the 0? you get 0 over 0. You got to do it again. So you're almost asking yourself, like, when do we stop? Well, think about it for a second. Now you get e to the x over 6. When you plug in your 0, you get 1 over 6. So your answer is 1 over 6. Okay? So that's how you do L'Hopital's. You're going to have to do it a couple of times in some of the cases. This problem came straight from the BC. So I hope that makes sense. And just in general, I wanted to point out that factorials grow the fastest. Exponentials are next, then the powers, then natural logs, and then sine and cosine are always between -1 and 1. So I think that's a important note to make, okay? Especially when we start getting into factorials. So I hope this video was helpful. Remind yourself that you have to get it into the 0 over 0 or the infinity over infinity form before you can do L'Hopital's rule. And anytime you get 0 over 0, keep doing L'Hopital's rule. Have a great, great day. Thank you.